Welcome to today's session, and welcome Lily and Jörg. Thank you for being here.
Yeah, thanks for having us.
Hi, thank you. Good to be here.
Thank you very much. I'm excited to talk about data reconciliation with you today, and let's jump right in. So let's start with the basics. What is data reconciliation?
Well, when you have different data sets and they have some kind of an overlap and you want to bring these data sets together, so to speak, you need a data reconciliation. You find the overlapping spots and merge your data set. So first of all, you have an alignment step, you have a merging step, and then you build your single source of truth out of it.
So people new to this topic might wonder, why do you even need data reconciliation, and what happens if you don't do it well? Can you comment on that?
Yeah, for sure. Maybe with one or two examples. Imagine you are an organization and you have a person sitting in front of desk working on data like for a credit check or something like that. And now this person needs to gather information from different sources of data, like different databases or even an Excel spreadsheet lying in some SharePoint environment. And then they need to gather everything and merge the data and build this view what's really going on about the person they are checking currently. This takes time, it's error prone, and in the end they don't take a well-informed decision and maybe create errors. And maybe a more harsh example, imagine there's a doctor doing a surgery in a hospital, and they need a certain information rather quick, and it's simply not possible to get this information because everyone needs to check different data sources, and in the end maybe someone even gets killed. So it's very important to have the single source of truth as said in the intro.
Mm-hmm. Yep. So for different industries, this can affect. Could you give some examples for the types of decisions that could be related to the reconciliation?
Yeah, sure. So I think, first of all, it's not so much about different industries, but basically it applies to every industry. So whenever you have a company that wants to make informed data-driven decisions, you need a good database for that. And if we talk about different industries, we could, for example, talk about retail, where you have sales data coming in from different sources, such as the physical stores, an online store, or maybe even some third-party vendors. And you need to combine all those sales into one concise database to get a unified view of your sales for making decisions about those sales strategies or about your inventory and so on. And another example would be if you are a manufacturer, specifically with regard to your supply chain. So we have a situation where we need to monitor our supply chain, and therefore we need to buy in data about our suppliers, and then we need to merge them with our own data and interactions with this supplier. And only if this happens in a valid way, that you actually combine those data correctly, you can make decisions about your supply or maybe even react to disruptions in the supply chain. Mm-hmm. So all of those decisions can happen at various levels. We have day-to-day decisions like the inventory stuff we talked about, but we also have medium to long-term decisions such as the sales strategy or marketing strategy. And very importantly, we also have very high-stake decisions. So for example, if you are a manufacturer and you're thinking about acquiring one of your suppliers.
Yeah, you want to make sure you get that right.
So even though it's not as high stake as the surgery example, but still, a lot of high stake decisions.
So I think it got clear that there are pretty unique challenges in some ways between different applications or use cases, but at the same time, it affects different industries on a number of different levels. But I wonder, is it always about combination of data, or is there also other use cases that are related to reconciliation?
Yeah, So finding this unified view is the most common use case, I think. I mean, also all the examples we mentioned were about that. But of course, there can also be other situations in which you need to reconcile data. Let's imagine you have a data provider and you're depending on all this data you get from this data vendor, but maybe the quality is lacking, or this vendor increases the prices. And then you are looking for another vendor to switch, but you need to make sure that this new vendor has the same coverage as the old one. Otherwise, you might have a negative impact on all the areas where you are using this data. So this would be one other example. Or also when you just want to migrate data so just the same data from one service to the other service, you also need to make sure that any potential differences are reconciled. So most often it's about merging data sets in some form, but it can also just be about mapping for different use cases.
Mm-hmm. And what are key challenges that organizations face when they go through reconciliation?
Yeah, I think the biggest challenge is probably the variety in the data properties. So we have different data types. Obviously, there can be data about just about everything, like entities such as persons or companies or products, machine parts. There can be data about events, price curves, and so on. And the nature of all those things is different. So the data about them must also be different. But even if you are talking about one specific type of entity, let's say a person, you can also have differences depending on the data source. Let's say one data source has information about the person's name just in one field, which is the full name, and the other one would be more fields like the last name and the first name.
Mm-hmm.
Yep. Just a simple example.
Mm-hmm. So these differences in the structure of the data, what are the practical implications or practical challenges this leads to?
It basically just means that you might end up with two completely separate and different representations of the same entity. And these differences in the structure or also missing information makes it difficult to bring those together. And if we go back to our example with the supplier, you might have a situation where in one database your supplier is called ABC Corporation, and in the other one it's ABC Corp. And of course, if you don't bring them together, you will have wrong information about this specific supplier, just that you, for example, don't know that your interactions from this one database are the same as the data you bought from a data vendor in the other one. Mm-hmm. And therefore, of course, all your supply chain monitoring regarding this supplier and all these connections surrounding it would be inaccurate.
And there are other challenges in real-world scenarios. The sheer amount of data is normally a huge issue. Like this one example with ABC Corp versus ABC Corporation is one pattern, corporation. But there are several other in the reality, and you need to find them all. And you need your rule set that you then define in order to tackle most or the most important cases, and do it on a scale so that you can really process the whole data set in a reasonable time.
Yeah, and let's not forget about other challenges which are more basic, I think, like architectural challenges. Let's imagine if you want to build an entity graph, for example, you not only need the architecture for this graph, but you also need a pipeline that processes all the different inputs going into the graph, which can be quite diverse, ranging from some databases to individual files, maybe even some real-time API access and stuff like that.
I see. So what are ways in which companies can address these challenges, and what are steps that commonly happen in this process?
Yeah, well, when you have this problem, you already have data, and that's good because many data science projects don't have the data and want to do something with it. Take a look at the data. What are the fields in there? What's the structure? Is it a table? Is it a graph? Is it a document database? What is it? And what do you see there? Are there errors that are frequently there that you need to tackle, like typos or different representations of numbers or dates and things like that? So do your data cleansing at first. Then define what you want to have in the end. So what shall be your output format? What's your schema that you want to have? Then convert all the data sources that you have to this schema, and you will find even more data errors on this path. And now you're able to do an alignment step. So you can now act solely on your data model and find the reconciliation candidates. So the documents, the nodes, the rows that might be the same from the different sources. Once you have this, you are done with the alignment step, and now you can render your final result. So what do you want to have? What's your goal? Do you want a database of all the persons in a database? Do you want to incorporate the email addresses or not? Things like that are now questions that arise. And you can even render different views for different use cases or different customers, different people in your organization.
Yeah.
So it's the one coherent view in the end where others now can take over.
Yeah. And we all know this can be quite a bit of work. So let's touch on tools and methodologies that can help with this. Can you comment on that?
Yeah, sure. So there are tools available in the market. Some even claim that they can solve this whole reconciliation problem for you. And while I think that those tools can help with certain aspects of the problem, so for example, if some cloud provider has an architecture that fits your problem, has the right databases you need, maybe even has some methods in place that can help you with steps that Jörg mentioned, such as cleaning the data or even mapping parts of the data. There is definitely no one solution that fits all problems. And most of the cases we are talking about are difficult reconciliation problems, and they are in its core difficult data problems. So every solution needs to be customized based on this data, so based on the actual data you have and on your business needs. And we at CID have lots of experience with reconciling entity data. So we have some methods in place for example, finding candidates for matching or also then actually merging them. And those are based on NLP methods, ML methods, statistics, and so on. And of course, this knowledge can easily be transferred to other domains. And we're always excited about new data problems and applying this knowledge to other domains.
Definitely. So let's take a step back and do some housekeeping for a minute. There are terms like consolidation, blending, mapping, or merging, and all these are kind of related to reconciliation. And let's clean up a little bit and maybe understand like what these mean. So can you comment on that?
Yeah, sure. So obviously those terms are not only related to reconciliation, but also to each other. They're highly intertwined in the way they work. Luckily, they're also often used interchangeably, so it doesn't really matter if you talk about consolidation or reconciliation, at least in most cases, because people will mean the same thing of kind of bringing data sets together. But in the details, they have some differences. So if we talk about data consolidation, we're focused on bringing together data from two different sources or many different sources into one consolidated data source. For example, a data warehouse or something like that. If we talk about data mapping or alignment, like Jörg said, it's about mapping the data fields from those different data sets. So it's not so much about the individual data entries, but about the structure of the data. On the contrast to that, merging is about actually bringing together the individual data entries. And yeah, you also mentioned blending, which is a way of finding a unified view of the data to work with without actually necessarily storing it somewhere. So it's more an on-the-fly ad hoc analysis kind of thing of working with the data. And in all of those processes, reconciliation plays a key role, because if you don't reconcile the data while merging, mapping, consolidating, whatever, you cannot make sure that the data remains accurate and consistent. And therefore, reconciliation needs to have some more advanced techniques of resolving all potential discrepancies between those different data sets.
Thank you for covering that. So let's get back to the practical side of things. And I wanted to ask you to maybe share a project or an experience where you solved a reconciliation problem during your time at CID.
Yeah, sure. Well, I think I'll start directly with the thing that you mentioned, Lily. We come from an entity perspective. So we have built a huge business graph. It consisted of about 100 million of entities, and these were organizations, individuals, and locations. It was served by different data sources with totally different schemas and data formats. And you can imagine that when we have 100 million nodes in our graph in the end and uncountable relationships, there were many more nodes in the original data source that we needed to merge. So this was quite huge. And maybe two different examples from projects that we did. One was in a financial services area where it was all about mapping data from two data sources that consisted of commodity information. We had price curves, we had structured metadata, and textual descriptions in order to map these derivatives. And we needed to incorporate all of these and build a multimodal system, which was highly individual for this problem. So an off-the-shelf solution wouldn't have helped at this point. And something from healthcare, we worked, and we still do, for a big healthcare company, which creates and sells products, and they apply for public tenders. So when a hospital has a huge list of things that they want to buy, they make this public on EU level, and then everyone can look at this tender and check whether it's clever to apply for it or not. And this process took them 1 month per tender, because it's such a long list of thousands of lines with different products that an hospital organization wants to buy. And then a person needed to really check, all right, they want to have product A, and I have, oh no, I don't have product A, but I don't have, but I have product B and product C, and they could be the same more or less, and then take this decision. And this took weeks. And we shrink down this process to 2 days for the whole application, because we could do a reconciliation step, which it wasn't even fully automatically. We provided a system which found the best matching candidates of products that our customer has to the one line in the tender. And then an expert could say, all right, this is right, this is right. Oh no, I'll take the second out of the list. And so the process was speeded up tremendously. And in the end, they now sell much more products because they simply can apply for more tenders.
Yeah. And I really think that this one was especially interesting because it shows that it is not always really the way to go to take the human out of the equation entirely.
Yeah.
It is just about putting it in the smart spot, right? So make all the decisions that you can automatically, and then have the expert take all the information at hand and make the informed decision fast, and just take the decisions that matter, maybe by a human if it is needed in a certain case. But yeah, so I really like that about this project.
Yeah, you have the highest quality that's possible, but you become so much faster.
Yeah, exactly. So let's touch on what happens after the initial reconciliation has been performed. In the direction of constantly changing data, obviously something needs to be done about that. And I wanted to ask you to comment on that.
Yeah, sure. So obviously, like you said, we have constantly changing world, constantly changing data, and every reconciliation algorithm needs to deal with that. So we might have changes in the data, such as new data entries or changes to existing data entries, or the data vendor might even change the whole structure of the data. So your reconciliation tool needs to deal with those updates, adjust the reconciliations accordingly, and importantly, you also need to have some form of checks or tests in place to make sure that there are no changes happening to the data that break your whole system and that everything remains accurate and consistent.
Yeah, definitely. So before we conclude, I wanted to ask about advice for companies starting out with reconciliation. What are the first steps that could be taken?
I think, first of all, you need to check what's your goal. So what are business requirements? What do you want to do with the data in the end? What quality do you need to have? Is it that you want to send out a newsletter to some customers, and it doesn't matter if you do a customer segmentation and one customer receives the wrong newsletter? Or is it really business critical because you do trades on large scale, and if you have a reconciliation error, you lose millions of dollars? So what's your quality requirement? And then, check the data. Look for steps that you need to take. Maybe some transformations. Maybe you can have tooling support. So check what's there on the market. And if you come to the conclusion that it all doesn't help, or that you won't make it in time, ask for help.
That's what we're here for.
Yeah, definitely.
So I think some key takeaways from today's session are that while reconciliation kind of applies to all industries in its own ways, the challenges that need to be tackled are kind of unique at the same time. And very often a custom-built and tailored solution that really fits your data landscape as well as your business needs is really the best way to go. Yeah, thank you very much for today's talk. This was very interesting, and thanks for being here.
Yeah, thanks for having us.
Thank you.
Pleasure.
As always.
Thanks. And thank you for watching. Please make sure to also check out the CID website, because these two also have blogs ready for you there, which dive a little bit deeper into the topics that we have discussed today. Thanks again, and bye-bye.